Hello everyone, Mr. Hein here. With the video on how to go over forms of a linear equation. This might be new to you, might not be, but it's something that's been coming up a lot in this curriculum and calculus, and it's important that you know this skill. Now before I start, just do a little bit of breathing to help us stay in the moment, stay here, and try to get rid of a lot of distractions as best we can, because there's always stuff on our brains, and I understand that. So the way you do it is be aware of whatever's on your thoughts right now, and just listen to the breath. All right? 3 times. Breathe in and out through the mouth. Make sure you're listening to your breath. If you're listening or thinking about anything else, that's okay. Bring it back to the breath. In and out. And last one through the nose only. In and out. Hopefully you feel a little bit better. Hopefully you don't really remember what you were thinking about before, and that's really a good sign. So, forms of a linear equation. Recall that linear is when the first rate of change is constant, which constant is just another word for the same. So if I gave you a table that looked something like this, 0, 1, 1, 3, 2, 5, 3, 7, what you would notice is that the first rate of change is 2, which this is a linear pattern. So we could actually write this as y equals 2x plus 1. 2 is because that's its rate of change, or its slope, and 1 because that's its starting value. And this actually relates to the first form, which is the one you're familiar with, which is graphing form, or they also refer to it as vertex form, which is y equals m x plus b. That's the simplistic view of it, but really the better of it is y equals m x minus h plus k. This is the simplified, where m is your rate of change or your slope. Make sure you start to understand that the interchangeability of those two words means the same thing. And h is your horizontal shift, and k is the vertical shift. But sometimes what happens is when we simplify this into y equals mx plus b, the b ends up just becoming the y-intercept, because if you plug in x equals 0, once this is simplified, that gets rid of anything here. You're just left with y equals b. So to give you an idea, so say you were given a point and the slope. So you have the point, say 1, 5, and the slope, and it says that there is a slope of 3. You would be able to write the equation y equals 3 x minus 1 plus 5, where the 1, 5 is the hk, or the x1, y1, sometimes how books refer to it. And that's acceptable. That's a good answer. But if you wanted it in a simplified view, sometimes they would distribute this out and they'd write their final answer as actually y equals 3x plus 2, right? And it's y equals mx plus b format. But both work. I mean, and at this point in calculus, as long as you have the right answer, you're fine. You usually don't have to simplify much farther when it comes to linear equations. All right, these are just saying different things. This one, well, not really, it's the same thing. Slope is still 3. This one just tells you the y-intercept of 2. This one up here, I mean, if I was to graph this to help you see this, show you that they're the same as a review. If I was to do this one down here, you would start at 2 as the y-intercept, and then you go up 3 over 1. And then if you continue that, that would be your line. Right? Now this one up here, you know a point on it is 1, 5. So you could go to 1, 5 and make a point, and then you have a slope of 3, in which, notice, you're on the same line. That's why either of these is okay. They're the same. But sometimes it's simplified as just mx plus b. Now the new one isn't that much different, and that is called point slope form. But this one comes in handy the most because it really creates the least amount of work for us on writing equations. And it's written as y minus y1 equals m x minus x1. All right, so if you're given a point and a slope, which is where the name point slope form comes from, and say it's a new problem of 2 comma 3 and a slope of 1/2. You could write y minus, when I put an equal sign, gosh darn it here. Y minus, that's x1, that's y1. So y minus 3 equals 1/2 x minus 2. And that is an acceptable way of writing a linear equation. You don't have to simplify it farther to get here, because this tells us everything we need to know. We know its rate of change. We know it's linear because it's just y to the first power of y. And then we know 1 point, which is all we need. Sometimes you'll see in the problem, I think this is relating to problem 1.9 in the classwork today. If it gives you 2 points, the sample size right here, that's 1 point. If it gives you 2 points, then you just have to find the slope and then use one of those points, and then you should be fine there. Well, let me do an example and I'll show you. So say you're given 2 points. You could write it in either form, but you'll see how point slope form is so quick. So say you had the point 1, 3, and 7, 10, right? Find your rate of change. So change in y over change in x, which in this case will be 10 minus 3 over 7 minus 1. It becomes 7 over 6. And once you have the rate of change, we could write the equation. Y minus 3 equals 7 over 6, x minus 1. And you don't need to simplify that any farther for point slope form. Okay. If you multiplied it all out, combine like terms, yeah, you'd get to like a vertex form, which tells you the y-intercept, but you could always just find the y-intercept by just plugging x equals 0 and doing a little bit of work. Well, hope this helps. If you have any questions, you know to visit me during office hours or email me. Bye-bye.